Okay, we're just going to talk a little bit about the post-lab questions on the separating a mixture by filtration. We had two different filtrations that we did. The first one, we got the charcoal, and then we got the salicylic acid on the second one. Those were the two solids that we were finding. One of them was black, one of them was white. When you mixed them together, it looked like a gray solid. So let's talk a little bit about, and I'm looking at some of the data that you folks just turned in. And one thing that I had with a couple of classes, or a couple of groups, in this class and in the previous class that we did things, earlier today, one of the groups had 2.85 for their original mass of the mixture. Now, the problem I had with that group's data was that, didn't you go back and get around 0.6 grams of the mixture? So that data to me cannot be correct because you didn't have that much of it. All right? So what I probably guessed on those is I said, did you have a measuring dish added in there? Okay. Was there a watch glass added in there? Okay. Did you measure your Erlenmeyer flask wrong? Because something could not be correct because you didn't have that much. You didn't have that much to start with, because I said get 0.6 and take it back, and then we'll go from there. All right? Now, when I did this particular lab, I came up with 0.52 grams. Now, one thing we need to make sure of as we're going through and making measurements, these were made on a digital scale, right? How far does the digital scale carry the number out? How many places? Yeah, Carly? To the 100th place. So whenever I'm making a mass on that digital scale, on the ones that are at your lab table, we need to have those values to the 100th. If you only have it to the 10th, you can do more. We can be more precise than just that 10th. The mass of the charcoal that I recovered was 0.24 grams. The mass of the salicylic acid was 0.27 grams. So when I add those two values together, the total that I recovered was 0.51 grams. Now, does that make sense? Does that make sense? It looks to me like I'm only 0.01 grams off. So I would think that that would be okay. I would think that that would be okay because I recovered almost all of the mixture that I started with. Now, I had a group earlier, tell me what doesn't make any sense here. Here's what the group earlier had. What doesn't make any sense about that? Kira? Right. We recovered more than you actually had to start with? How can that be? Okay. Did you just create some of the stuff somewhere? Probably not. So some kind of error in a measurement somewhere, because I'm fairly certain that when you filter stuff, you don't create more of it. All right. So let's go back to my value here, the 0.51. So I'm looking at this and I need to make some calculations. The first calculation I need to make, and I'm only going to do trial 1, okay? I'm only going to do trial 1, not trial 2. So I need to take the total mass of the recovered solids. I just said that that was 0.51 grams, okay? I need to take the original mass, 0.52 grams, and I need to multiply that by 100. So when I do my math, the 0.51 divided by 0.52, multiply that by 100. How many sig figs should I have? How many sig figs should I have? Kaylin? 2 sig figs, because right here I've got 2. Right here I've got 2. Remember, this 100 is what we call an exact value. We do not use exact values when calculating the sig figs. Okay? So I have 2 sig figs on the top, 2 sig figs on the bottom. So when I did my math, I came out to 98% recovery rate, which I think is pretty good. I think that's a pretty doggone good recovery rate for us in here. Now, what could have happened? What could have happened? Why I didn't have 100%? Well, maybe there was still some of the charcoal in the Erlenmeyer flask. You didn't transfer all the charcoal over. Okay? Maybe some of the charcoal passed through the filter. All right? I'm giving you a different reading for your salicylic acid. For each trial, divide the mass of the recovered charcoal by the total mass of the recovered solid, multiply by 100. Well, the total mass of the recovered solid was 0.51 grams. Okay? The mass that I had of the charcoal was 0.24. Multiply that by 100 to give me a percentage. So I'm taking 0.24. I'm dividing that by 0.51, multiply by 100. It gives me 47%. So based on my data, I'm saying I had 47% charcoal. And my next one is going to be the salicylic acid. So that's going to be the 0.27. So when I take the 0.27 divided by 0.51, multiply by 100 to give me my percentage, I get 53%. Well, 47 and 53%. Okay, that makes sense, doesn't it? Now, the thing about this, where we're going to test to see the accuracy of my lab, okay, because it looks like right now I recovered 98%, okay? I recovered 98%, so that's pretty good. But I said that there was 47% charcoal, okay? When I made up these mixtures, I had about 40-60. So 40% was charcoal, 60% was the salicylic acid. So when I go through and say, okay, well, how accurate was I with my part here? And I'd say, okay, I said that there were 47, wasn't it? 47 was my experimental percentage. Okay? Well, I know that I had 40%. So when I divide that by 40%, multiply it by 100. Now remember, we've been having some troubles with this percent error. Remember, percent error is the absolute value of the experimental minus the theoretical divided by the theoretical. I was getting all kinds of different things on percent errors. Okay, all kinds of different things. So when I take this and I divide this out, I'm taking 47 minus 40. That leaves me with 7. So it leaves me with 7 divided by 40 times it by 100. So you see how many sig figs I'm going to have here? I've just changed that to 1 sig fig based on my data. So I take that 7, I divide it by 40, multiply by 100, and I get a value of 17.5. And that's going to be percent. 17.5%. But that's too many sig figs, isn't it? What did we just say how many sig figs we could have, Cody? 1, right? So I've got to make that into 1 sig fig. So I'm going to make that, how do I make that into 1 sig fig? What do you think, Tyler? Okay. Okay, 7's bigger than 5, so I'm going to round the 1 to 2. 20% with no decimal point. Excellent. So my percent error, based on what I knew I mixed up, was about 20%. So that's probably not really very accurate, but let's talk about why it's not. Okay? This is what we call a heterogeneous mixture. If I go in there and scoop some of it out, does it necessarily mean I'm scooping 40% of the charcoal out? Could I have a little spot that might have, a big concentration of charcoal and a smaller concentration of the salicylic acid? Yeah, that could happen, right? That could happen. If I have M&Ms, okay, and I have 40% red and the other 60% green, does that mean I'm always going to skip, if I scoop out M&Ms, I'm always going to get that percentages? You're not always going to do that, all right? So that's why it was probably a little bit off, that 20% air that I just calculated, because my scoop could have had a lot more charcoal than in that particular confined area, okay? Any questions about this? All right, sweet.